Today in this video we are going to learn about Kirchoff's rules and how to apply them on the circuits. The first rule given by Kirchhoff was junction rule. According to it, the amount of current entering a junction is equal to amount of current leaving the junction. Now what does that mean? If you see this diagram, here it is a junction and few currents are entering the junction and few currents are leaving the circuit. As you can see, it is a junction and at this junction I1 is entering, I5 is entering and I4 is entering. The current leaving the junction is I2, I3 and I6. So according to the junction rule, the amount of current entering is equal to amount of current leaving the junction. In other words, we can say the algebraic sum of current at a junction is 0. By convention, you can take the sign positive for the current entering and the current leaving the junction you can take sign as negative, or you can do in this way only, that amount of current entering is equal to amount of current leaving the junction. The second rule is called as loop rule. According to loop rule, the sum of all potential difference around a closed loop equals to 0. So the mathematical form for this loop is summation of potential, that is V, is equal to 0, or you can say summation of IR, because the value of V is I into R, is equal to 0. We have to understand that how we have to apply this loop rule in the circuits. The theoretical form is easy. Everyone can learn that sum of all potential difference around a closed loop equals to 0, but we have to learn how we have to apply this rule in the circuits. So before starting the application, there are some sign convention that you have to learn. The first sign convention is for the term IR, the product of resistance and current, that is the IR term in any arm of the circuit is taken positive if one moves in a closed path in the same direction of assumed current and vice versa. So if your direction of loop is in same direction with current, the product of I into R you will take as positive, and if you're in opposite direction with the current, then you have to take I into R as negative. The second is for the EMF of the cell. If your loop direction is from negative terminal to the positive terminal of cell, then EMF has to be taken as positive and vice versa. In the initial stage, you might find it very confusing that how you have to apply this, but the next application will tell you that how you have to apply these sign convention in the numericals. For example, here is a circuit as shown to you. There are two loops. One is this and the second one is this. So the first thing that you have to do is you have to apply the junction rule. As you can see, here is a junction, and according to junction rule, what was the point? That the amount of current entering the junction is equal to amount of current leaving the junction. Now if you see, I3 is entering the junction, I3 is entering the junction and I1 and I2 are leaving. So I3 is equal to I1 plus I2. This you have applied the junction rule. Now the most important part, the loop rule. See, here it is a closed path or a closed loop. The first thing that you have to do, you have to assume direction of the loop, either clockwise or either anti-clockwise. It totally depends on you. There is no compulsion of using clockwise only or anti-clockwise. It only depends on you. But the thing is that you have to apply sign convention properly. Answer you will get. So for this loop, I am taking direction from, I am taking clockwise direction. Okay. Now as you can see, the direction of my loop is from positive terminal to the negative terminal. Now if you see the convention, when you are moving from negative terminal to positive, then it is positive. In this case, I am going from positive to negative, so it has to be taken as negative. So I have written minus 20 over here, as you can see. Now when you move further, there is a resistance of 20 ohm and the current flowing through 20 is I3, and when you are moving, if you see, your direction and current direction is same. Again, see this, when you are moving, your loop direction and I3 is in same direction. So when they are in same direction, it has to be taken as positive. The IR term is taken as positive if one moves in a closed path in the same direction of assumed current. So this becomes plus 20 I3. Okay, if you go further with the direction of a loop, the next resistance that comes is 30, and the current flowing through it is I1, and it is also in the same direction of the loop, right? See again, going like this, and it comes 30, and you are in the same direction with the current flowing through it, I1. So it becomes plus 30 I1 equals to 0. The algebraic sum of potential is 0. Okay, let us see next loop. If you have not understood this loop, the next loop can help you again. Assume the direction first. I am again taking direction as clockwise. Now I am moving from negative terminal towards the positive terminal. Now if I move from negative to positive, then EMF has to be taken as positive. So this 80 becomes plus 80 over here. Now if I move further, the resistance that comes in my way is 20, and the current is flowing in this direction, and I am coming in this direction, that is the opposite direction. So it becomes 20 I3, but in negative, minus 20 I3, because current and my loop direction are in opposite directions. So if I move again, now next resistance that comes is 20, and the current flowing is I2. So I2 is coming like this, I am coming like this, again it is the opposite direction. So minus 20 I2 equals to 0. This is the way that you have to make equation from the loops.